Friends, welcome back to my YouTube channel. So in today's video we will see a moment area method for simply supported beam. So in last video we have seen the moment area method for cantilever beam and we have also solved some problems on that. Today we will see a moment area method for simply supported beam. So now consider a simply supported beam. Here the load W is acting. This is the point support A and support B. So in case of simply supported beam, what happens here is the load is acting at the center, means it will deflect like this. The deflection will be like this. No, here what happens is the slope is maximum at point A and here also the slope is maximum at point B. So call it as theta A and theta B. In case of simply supported beam, the slope will be maximum at the end points and at center the deflection will be maximum. So deflection will be maximum at center and slope will be maximum at end points. And at center the slope will be 0 and deflection is maximum. At the end slope is maximum and deflection is 0. So in case of simply supported beam, so I will write it here. So at end supports, slope will be maximum and at middle or at center the deflection will be maximum and at center slope will be 0 and at end support the deflection will be 0. So this is about simply supported beam. So if you consider for example, if we take here this is the load, point A, point B. For this the bending moment diagram will become, it will be like this. No, bending moment will be like this and at center, so here the bending moment value will be WL divided by 4. Here the distance of L by 2 here and L by 2. So what happens for this, if you want to find the bending moment at point B, then the distance of CG, here the CG will come, we need to take the where the slope is maximum. If you want to find the bending moment at point B, then you need to take the distance from here to here, because here at end support the slope will be maximum. No, we need to take the always CG distance from the where the slope is maximum. Whenever you finding the bending moment, we need to take the distance from at the point where the slope is maximum. Here at point B the slope will be maximum. No, and if you want to find for the similarly for support A, if you want to find the moment at point A, then we need to take the distance from here to here, because at point A the slope will be maximum. No, we need to take the distance from the point where the slope will be maximum. So this is about simply supported beam. Here to find the CG distance from here to here, we have the, so to calculate the area we have the formula half into base into h. Similarly to find this distance we have the formula 2 by 3 into L, and here we have the formula 1 by 3 into L. So 1 by 3 into L. So I will show you how to calculate for this. Here the load is acting at the center. No, you don't need to find for the both the support. If we calculate for the support B, the answer will be same for the A support also. You don't need to find the whether, if you want to find the bending moment, you need to calculate for B, then you can write it A is equal to B, because it is acting at the center means the answer will be same. I will show you. This is the BMD diagram. Now the M divided by EI diagram will be, so it will be like this, WL divided by 4EI, point A, this is the point B. So it is center acting. No, the distance will be here also L by 2, here also L by 2. To find the slope, here the elastic curve will be like this. At center our deflection is maximum. At point A, here it will deflect like this, no, and it also deflect like this. Here also theta slope is maximum, here also slope is maximum. Now to find the theta A, here the theta A is equal to theta B. For that we have the formula half into, to find the area of this one we have the formula half into base into h, no, half into base is from here to here is, here to here distance is L, total distance is L, no. So now we are total distance is L, we need to find the, for this triangle I am finding, here the distance will be L by 2 from here to here. Here the length is L by 2 and the height of this will be W L divided by 4EI. WL divided by 4EI. So you solve WL square divided by 4 4 ja 16 EI. This is the theta A and theta B, the value of slope at point A as well as at point B. This is how we need to find. If you find for the one slope, the another answer will be same, because the load is acting at the center. Now we now need to find the both the answer. Now similarly, for when you find for the deflection at center is maximum, now to find that we have the formula. So we have the moment area of, we need to take the area of M divided by EI, no. This is our M divided by EI diagram. We need to take the moment of M divided by EI diagram we need to take. For that we have the moment of M divided by EI. For that we have the formula, moment formula, area into distance of CG. Distance of CG for this, here we have 2 by 3 into L. 2 by 3 into L. If you want to find this one, this is 1 by 3 into L. Now we need to find the deflection. Now we are finding the maximum deflection. So maximum distance I am taking at point B with respect to B. I am taking area into X. Now we need to separately for this half into, so base of this one will be how much from here to here is L by 2. L by 2 into height of this one will be WL divided by 4EI. WL divided by 4EI. This is our area. So now our X distance, X is nothing but CG distance of this one. What I have said, we need to take the distance of CG from where the slope is maximum. See here from at point B end point our slope will be maximum. No, we need to take from here to here distance. Here to here distance is 2 by 3 into L. L is nothing but our L by 2. So 2 by 3 into L value, we have the L by 2. Put that. So if you want to find the deflection, maximum deflection with respect to point A, then also you can go with the same problem. I will tell you here only. CG will come and from slope is maximum here, no. Here 2 by 3 into L. Here 1 by 3 into L. So if you want to find for this one, we need to take the same, the value will be same, the area will be same, and the distance from here to here is 2 by 3 into L. 2 by 3 into L is here L by 2, same. L is L by 2. The answer will be same. 2 will get cancelled here. Now solve it. W into, here one L is there, here on L. W L cube divided by 2 2 ja 4 and 4 4 ja 16. 16 3 is 48. 48 divided by EI. This is the deflection, maximum deflection at point C. So call it as the point C. Here the maximum distance at point C will be WL cube divided by 48 divided by EI. So now we can, this is how we need to find the deflection. So now I will solve for the one more. I will show you how to find. I will draw here. So whenever the beam is carrying the UDL like this, here also load is acting. So the maximum distance, the bending, So BMD diagram will be, it will come parabola like this. Here the bending moment will be at center WL square divided by 8. Here at center the bending moment will be maximum, and if you go for the M divided by EI diagram, it will come WL square divided by 8 EI. For this it will deflect like this. Maximum deflection will come center. Again at point A will be the slope is maximum. Here also at point B the slope is maximum. End point slope will be maximum here at both point A and B. So now to find the slope for this, to find the slope, theta A is equal to theta B. We have the for parabola. Here for parabola we have the, to find out the area we have the formula. To find the area we have the formula 2 by 3 into L into H to find the area. To find the CG distance, the CG will act here. To find the CG distance from here to here, we have the formula 5 divided by 8 into L. To find from here to here distance, we have the formula 3 by 8 into L. I will write it here, wait, clearly. CG will be here. To find this much of distance, 2 by 3 into, 5 by 8. 5 by 8 into L. To find this distance here to here, 3 by 8 into L. To find the area of parabola, 2 by 3 into H into L. So now we will solve it. To find the slope, we have the area of M divided by EI diagram. So this is M divided by EI diagram. To find the area of this, we have the formula 2/3 of length of this one is here to here L by 2, and height of this one is WL square divided by 8 EI. WL square divided by 8 EI. So 2 will get cancelled. So WL cube divided by 8 3 is 24 EI. This is the maximum slope at point A as well as point B. So now if you go for the similarly, to find the deflection, maximum deflection, we have the, for that formula, moment of M divided by EI diagram. So moment of M divided by EI diagram, we need to find the maximum deflection. For that we have the formula. So our moment formula is area into distance of CG. Area into distance of CG. You can take either this one or this one or this one, whatever. So area of, now I will take this one. So to find the area of this one, we have the formula for area 2 by 3 into length from here to here is L by 2. Here to here is L by 2, no? L by 2, and height of this is WL square divided by 8 EI. WL square divided by 8 EI. This is our area. So now we need to find the CG distance. Now for this, here we need to take the CG distance where the slope is maximum. At point B the slope is maximum. Now we need to take from here to here distance. Here to here distance, we have the formula 5 by 8 into L. 5 by 8 into L is our L divided by 2. Length we have L divided by 2. So 5 by 8 into L divided by 2. So now you can solve it. 2 will get cancelled. Here W total L to the power of 4 divided by, if we 8 8 is 64 and 64 6 is 8 8 is 64, 64 6 is 384 divided by EI. So this is the maximum deflection. This is how we need to find the slope and deflection. Keep the file. I hope you all are understood. So in next video we will solve a problem on this. So if you like the video, like it, share it and subscribe for the more videos. Thank you for watching.